Hello everyone, Icaro Cesar here. Well, over the past 3 weeks, I've been spending some time studying LLMs, how they work, and how can I use them effectively to improve my productivity. And after a few personal projects, I developed a plugin for Binary Ninja, which consists in a MCP server, which allows an analyst to have AI-powered assistance for malware triage and automation of some reverse engineering tasks. It's focused particularly on creating triage reports with some automated insights or threat intelligence of this malware. Well, this is the project's README, which by the time that you watch this video, it's already on my GitHub and the link is in the video description. So let's get started. Well, but first I will be testing this with the Velatrix loader, which I analyzed in my last blog post. You can find my entire write-up here, but let's see what my MCP server can provide as a triage assistance. So let's get started. But first, you will need a personal license of Binary Ninja to use the Binary Ninja API. After copying the repository folder to the Binary Ninja's plugins this, directory, which you can find here, open plugin folder. Here, there is the plugins folder of Binary Ninja. When you copy the directory of my project to here, you just need to start again the Binary Ninja and the plugin will be loaded as we can see here in the Binary Ninja's logs. So let's load the malware into Binary Ninja and start the MCP server. This is the Velatrix loader, the drstat.dll. So let's load it to Binary Ninja. Okay. Okay. Let's clear the logs. And that is. Okay. Now, the MCP server, you can start here and plugins 0x0 the MCP server and start server. So that is MCP server has started. You can see here the logs. They are listed on port TCP 8755. So, okay. Well, let's use some LLM agent software and desktop. I personally use Claude Desktop. So I create a script that can, not this is, yeah, it is. I create a script that automatically configures the settings for Cloud Desktop, and it is also available in the repository. So if you use Cloud Desktop, you just need to execute this script and the Cloud Desktop will be configured automatically. So, okay, let's go. Okay, here in Cloud Desktop, you can see the tools loaded here from my install MCP server. These tools will be used by Cloud to collect information. This way, he can create a triage report with insights for his analysis. I develop a long prompt. Let's copy here. Yeah, that is. That is? Yes, that is. I develop a long prompt so that Cloud has all necessary context here. Okay, yeah, it's very long. I like to write. So the Cloud has all the necessary context and knows how to return exactly what I want. So I just passed this prompt here into Cloud and wait for a Cloud returns. So let's do it. Okay, he's thinking. It's cool, see he's thinking. Okay, he start to use some tools. Analyze entire binary is one of these tools. He turns all data needed to develop and analyze, and he produce their analysis. Okay. He use another tool, list all functions. Okay. Analyzing 64-bit Windows DLL with 353 functions. Let's see the logs in Binary Ninja. It's so cool. Here's the logs. Okay. Yeah. Okay. So let's wait. Oh my God, where is Claude? Okay. Use another tool, get current function HLEL, get current function disassembly. Here we can see disassembly code of specific function. dr data stop is the function. Okay. You get the strings here with minimum of h. He found 164 strings. He searching the web of the SHA-256 that I sent to him. Okay. And he's extract key informations. Okay, Claude, please. Please give us a good report. Oh, this is my blog. This is so cool. He's searching my blog. Okay, okay, Claude. That's nice. Let's back there. Sorry. Okay. He start to produce the triage report. Okay. So as we can see, they get the SHA-256 that I give to him. He can do the executive summary, key finders, he, correct attribute to China Nexus. Okay, target Chinese telecommunication. Probably he take this information from web. DLL side loading, yes, via legitimate wonder share software. Okay, technical characters. Okay, let's do it. Language, C, C++, compile with Microsoft Studio. Okay, it's a DLL. It's not packet, yeah. Dynamic API resolution, load library, and get proc address, correct. String obfuscation, stack based string construction to hide API names, yes, correct. This is very interesting because he can see that this malware use this technique of API obfuscation technique to hide, to obfuscate his shellcode. Oh, you see here the shellcode key decryption and the key of decryption of C2 communication. Okay. It's a good report, as you can see. Okay. Let's see details. Oh, Mitra tag, TTP mapping, cool. Malware behavior catalog mapping, very cool. Indicators of compromise. Okay. CN rules, network detection, campaign tracking patterns, infrastructure hunting. Okay. So as you can see, it's a very, 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 to me particularly, it's automation of the task that I do uh, every time when I will analyze some new malware that I didn't know. I search all of this context before. I search in all of the public reports and use a tool that can automate this and create a very good triage report. It's nice. It's really, really, really nice. Okay. Well, uh, this particular malware, as you can see, contains obfuscated encrypted shellcode within. So let's get this shellcode and see the analysis of shellcodes, which are different from P files. Okay, and sometimes it's difficult to analyze especially by automated tool like this MCP server. So okay, let's do it. I will close this. Okay, I will close this report. So the script for extract the shellcode is here in my blog post, right at the end here. Oops, here. Python script to decrypt the Electrix shellcode. You just download this script and execute. He's contain all the obfuscated shellcode. You just run and he will decrypt the shellcode. I already decrypt and I close binary nation. I don't know why. So let's open again. Okay. The shellcode is where are you? I think I not execute the shellcode. So let's execute the script. Electrics. So let's execute. Where is his name? Python. Electrics. And okay, here it is. Shellcode payload dot sc. Let's open it. Okay, it's Windows 64. Okay, let's open. Okay, this is the shellcode. Here is. So let's start the MCP server again. Okay, and again, once again, I develop a prompt for Claude and I just passed it here. So let's see. Here is the prompt and here we go. Now let's wait and see what he returns. Okay, yeah. List all functions. Prepare a comprehensive shellcode analysis with technical precision. Get function details. And let's wait. Get current function HLEL. Here it is, the pseudocode. Cool. Analyzing PI hash resolution. Cool. He identified. Okay. Analyzing Velectrix loader shellcode. Okay. I think it's work with shellcodes too. Analyzing shellcode's entry point. Preparing comprehensive technical analysis for electric shellcode. I think it's work. Very good, my assistants. Okay. Okay. Electric shellcode deep dive technical analysis. That's so good. That's so good. Look at this. Okay. He found each hash value and resolved the API. That is cool. A pseudocode to connection establishment. Data reception payload handling. Okay, it's a good report. Hard 13 hash algorithm implementation. Okay. And all multi-stage payload delivery chain. It's so cool. Oh my gosh. He don't stop. So, as you can see, he was able to analyze and produce a nice triage report for the loader, the P file, and shellcode too. It it was necessary for me to confirm, of course, some information he provided and delve deeper into analysis. And he won't stop. He can he will continue to write an excellent report. That's so cool. That's so cool. So that is, folks. I hope you enjoy it, and I hope this project helps you with your analysis or through insights into how AI can automate some of your manual tasks. So, bye bye and contribute.